Hey there, it's Modern Retro Tech, and today we will be doing Advent of Code days 2 and hopefully 3. I haven't looked at the tasks yet, so I have absolutely no clue what's coming. I'm trying to avoid spoilers as much as possible, so I'm almost never using Twitter nowadays. But let's jump straight into that and look at it. We'll be doing stuff in Rust as usual. Let's see what the day 2 brings. Your flight departs in a few days from the coastal airport. Oops. The easiest way down to the coast from here is via toboggan. Toboggan? It's a simple sled traditionally used by children. Okay, I know the scene. The shopkeeper at the North Pole toboggan rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if we can take a look. The password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect when they were chosen. To try to debug the problem, they have created a list, your puzzle input, of passwords according to the corrupted database and the corporate policy when that password was set. For example, suppose you have the following list: 1 to 3 A, B, C, D, E, 1 to 3 B, C, D, E, F, G, 2 to 9 C, 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 many C's. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of items a given letter must appear for the password to be valid. For example, 1 to 3A means that the password must contain A at least one time and at most 3 times. In the above example, 2 passwords are valid. I guess 1 to 3A thing is valid. 1 to 3B thing is invalid. 2 to 9C thing is probably valid because, yeah, it's valid. So like the first and the last one are valid. The middle one is invalid. The middle password, blah, blah, is not. It contains no instances of B, but needs at least one. The first and third passwords are valid. They contain 1A or 9C, both within the limits of their respective policies. How many passwords are valid according to their policies? To begin, get your puzzle input. Yeah, we will be working with Rust, and we will be also working a bit if we will have enough time on our infrastructure. Last time we did this little REPL interface where we can execute days and parts of the days and also use custom input without recompiling stuff all the time. So we will extend it today, I hope, and hopefully we will solve days 2 and 3. Let's look at our input. So that's a lot of stuff. I will just... Yeah, and there seem to be all corresponding to this format. So it should be pretty easy to use it. Let's save it. That will be our day 2. As usual, we start with parsing things. So in this case, let's create the 2 Rust. How many passwords are valid according to the inputs, to the policies? That is good because we also will need to still use integer. So our type signature for solve function still works, but eventually we probably will need to extend it to work with our REPL interface. So we still will need to parse stuff, right? So we will have function parse. Yeah, and we just say, I don't need this anymore. Passwords, which will be parse input. what do we want to get? We probably want to get some kind of struct. So in this case, it will be password. What will it contain? It will contain policy thing, which will be some policy struct, and it will contain the password thing, which will be just string. And policy thing will be lowest number of repetitions, so like letter, which probably will be like char, I guess. I will be very dumb and just do string because I actually don't remember char Rust. How is it? Is it? Yeah, it's Unicode Scholar. Well, okay, we can use char. I think I never used chars in Rust before, so lowest will be U. I would guess U32. We cannot have lowest that is below 0. And we, so unsigned integers there are, and I don't imagine we will have something that is 64 bits here. So, and actually, I can just call it min and max for shortness, also 32. So that's our data model. That's what we will get in each of the entries for each password. And now we can try to parse stuff. So what do we do first? When we get input, we trim end, I guess. By the way, I wonder if my Rust analyzer thing is working. Oh yeah, I forgot. We need to add module here so that it starts to execute stuff here, actually. Yes, okay. Now, so we trim input. We then split it by strings, by lines, sorry. And pattern, by the way. Should I use pattern? Okay, it's implemented for char. Okay, splendid. So I can actually do this. I guess there it will be probably a bit faster. So that is each line. And then for each line, we need to map it. So we take a line. And this line we also split by actually, we will do here regex, I guess. So that is something that we will need to add as far as I recall as dependency, right? So I'll make it compilable for now, I guess. And yeah, I'm trying to develop a new habit of opening stuff in another window so that I can verify that I'm not showing anything I don't want to show exactly. So that's better. So we will need to use regex to parse our input, those password databases things. I guess. Oh, build something. I feel when we try to run this build at the same time as Rust Analyzer is building stuff, it breaks. Oh no, that's already my problem. So yeah, of course. Just say none for now. So now stuff should work. Yeah. So Let's do this map. We need to use this stuff here, so we will use it. And then we can define a regex, which will be so in the beginning of the string. Oops, I'll just do it like that. We will have a digit, then we have another digit, then we have a space, then we have alphanumeric character, which I quickly need to look up. So W, of course. Then we have two dots, and then we have number of letters that is larger than 1. And then how is it? Yeah, here are the groups. It's named capture groups. Yes, please. God, the syntax is so ugly. I never like them, but what can you do? So we have this stuff, which will be then low or min. Let's be consistent in our naming. Yes, this is min. This is max. This is letter. And this stuff is password. So then how do we get this stuff? So regex new blah 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 unwrap, sure. And then we can use it with match, shortest match. Let's see how it calls it. Replace. Yes. Is match find captures. Find capture location captures. Okay. Replacing the named capture group iterates in over capture groups. Sorry, it's always regex is always something that you use once in I don't know, a month, and then you forget it before you use it next time. So captures iter. Oh god. So does it work with this captures iter of the non-overrides in text capture matches? Months. So replace all. It doesn't really allows you to get matches by name or what? Same, except it yields information about capturing group matches. Okay, I guess let's try it. Capture names. Oh, it's rather over capture names. Okay. Just capture iter, then capture iter, and here we say do I want to take an iterator? I would rather get something like a dictionary that returns capture name to capture thing, right? Capture read add find it. Oh, I guess I got it. I can just collect it, I guess, into a vector, which, by the way, I can make it a bit smaller so you have a bit more space. Yes, then I can just match in this stuff, I guess. Because I think it will be only one thing, right? And then, okay, it doesn't return anything. Let's see, capture iter. Just capture matches with item captures with you can here it's the method name. If name isn't valid, capture group is match instance and none is returned. So then I can say capture name and say min. Oh god. That doesn't look very beautiful, but what can you do? Capture name max, capture name letter, capture name password. It should be some min, some max, some, come on, letter, some password, or alternatively it should panic invalid password format. Now I'll just do this. I hope it implements debug. And then we can finally build our thing. So password will be policy, which will be policy, and it will be password, and policy will be min max letter. So that's how it looks. Now it doesn't like something. What don't you like? It requires what? Oh yeah, we forgot to give it actual string, which is line, and accept struct found reference. Really, can I do it like that? Then capture should be captures. Yep. Found string. Oh, so then we also need to convert them. Gosh. That's one thing where you start to be sad that you're using statically typed language. So it's like use32. Actually, into. I think. No. Oh, there is magical parse method. No. Oh yeah, that is the. It's not string. I'm so dumb. Yes, a string and then, gosh, parse u32. Come on, unwrap. Yes. So that's min and max, and then we got letter. Can I do it in char? Sure, that we already consumed. And then we have password. So, what don't you like now? It's nonce, copy, slice, captures. Yeah, we can actually take this. Oh, I'm dumb. I don't need to do this stuff. I can just do next, which then should give me some captures. And then I also need to handle non-case, which I will also panic non-match in line in input. And in the end, all the stuff I can collect into a vector and return this stuff. So oh yeah, it should be a method, of course. Whoa. Let's see if that stuff works. So I will just do this to check. And yeah, we need, of course, derive debug on those. Which then allows us to use our REPL thing. Oops, we need to add command. Yeah, we will need to solve it eventually, of course. For now, yeah. And here we need to change type. So non-match in line in input. And we can here report our line, right? So D. Is it our first line? No. Maybe, I guess it can be because we are password. We end with that, right? So it can end with new line thing. GZD 1415. Mean. Oh, yeah, it's not one digit, it's multiple digits. So that can be the solution here. Oh, and yep, we have parse stuff. So sadly, it's not a real REPL. Otherwise, we could have looked at the first thing here, right? Let's now write a quick test for that. Here we'll have test parser works, where we just say I wonder how we did in first day. So that stuff I can close. Oops. Did we always use yeah, we always write files. Okay, let's do it for now, but we also probably need to have some kind of helper for this stuff because we will be doing it a lot. So read to string. Which and file will be this inputs t2. Then we can do parse input. And then of course we should do this so that we have an ability to compare things. So I wonder if it will work. So I can say password policy password 89 NNN stuff. So 8, 9 N and letters NNN. Oh, let's do it like that. And of course we need to close down. Okay. And let's take also, let's first check that this test runs. Yep. Now just to check that it also breaks when it breaks, let's do this. Yep, it breaks. Yeah, we can see correct output here. So can fix it, and we can add some other conditions here. So for example, let's take, this was 0. Let's take last line. I wonder how many lines is in this stuff. 1000. So I guess we have terminal empty line, so 999, and then 998 should be the last one. So let's check that we are reading that correct too, which will be 415 and B, and then this string. So something breaks. Q1011. Oh, I guess. Ah, yeah, because we are doing terminal thing, I guess. Not sure. Let's try it again. Yeah. Okay, that works. now let's actually solve the thing. I guess the parsing is the most complicated part here. So we did parsing, and now we can, yeah, we can again use our REPL to check it out. Now we need to just how many passwords are valid. So we just need to do parse iter into iter fault. So our initial thing is 0, 0 passwords are valid, and then we get password, and then we check. So we just do password is valid. Oh yeah. We first get accumulator, then we get the value. So accumulator password is valid, accumulator plus 1. Actually, that I can even write simpler, right? I can do filter password is valid, and then I can do count, I guess. Yeah, and let valid count, and then here we return some valid count. Oops, not parse passwords, of course. So this thing does not yet exist. Can we implement it? Okay, we can implement it manually, I guess. So we go implement password, and here we do fn is valid, which accepts a reference to self and returns bool. And then we say if. So we need to make sure that we have this letter in the amount specified by the ranger. So we first just count the letter. Count letter, which will be, letter count, policy letter count, where we just say self policy, self password, and then we say chars, and then can we do count or do something like, you can just do also filter, I guess. Let's say this is letter equals to self policy letter, and then we just do count, and then self policy min is less than equal than actually policy letter count is larger or equal to this min thing, and it's less or equal to max in, right? Okay, what don't you like? Can compare char with? Sure, you can. Expected found U32. Did I call it U32? Oh yes, I am dumb. Of course, it is usize. It will make it simpler. So it's usize because it's a counted thing, and counts of things are better represented as usize. All APIs in Rust that return sizes will return you this usize thing, or like lengths, count, and stuff like that. And the fix is very simple here. Right. And now, in essence, we can just do cargo run again. Something is not working. Option So we need to return usize here, and here it will break our REPL, I guess. Yep, exactly. So that is just option of, actually let's make it an option of string, I guess. This will be simpler because then we can do it's ugly. Okay, I will for now keep it at as I64. I will just make this and then return it. Can I do into? Can I do try into? Something like that. Let me quickly check it. Just S. Okay. So now we should be able to run it. So 538. Let's try this number. Yeah, we solved the first part. So as you can see, the challenge itself was essentially this and this. The main thing was parsing, which was this thing. But we parsed everything, and now we can start with part 2 once we quickly write a test for the part 1. So we got this parser works test, right? Part 1 solved, and we can just say assert equal, right? And that, of course, should be a test. Let's first set it to 0 to make sure that we will see that it fails. Yep, test failed. You can see that we got 538. And 538 is the right answer because we know it from our website. So we can then run our tests again. And we did it. So another thing, since we will probably be refactoring stuff, I will quickly commit it. And then we can continue to part 2. So let me make it a bit bigger again. While it appears you validated the passwords correctly, they don't seem to be what the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realized that he just accidentally explained the password policy rules from his old job at the sled rental place down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes describes two positions in the password, where one means the first character, two means the second character, and so on. Be careful, Toboggan corporate policies have no concept of index 0. So it's one indexed. Exactly one of these positions must contain the given letter. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. Given the same example list from above, 13A is valid, position 1 contains A and position 3 does not. 13B, 1, 2, 3 is invalid. Neither position 1 nor position 3 contains B. 2 to 9C is invalid. Both position 2 and position 9 contain C. So only one of those should contain the position. should contain the latter, not both of them. How many passwords are valid according to the new interpretation of the policies? Okay, so I guess we are changing our filter condition. In principle, we normally would also need to rename our stuff, but I guess we won't because we are too lazy for that. And it's part 2, not part 1. But let's call it is valid 2. So those are just positions in a password, right? Self password is this indexed? Can I do self policy min? Will it work? Let's say false for now. Can I use chars? Maybe it has something like at. Okay, let's quickly check our string thing. So this method would take usize index range container index separation. So index is implemented at that, right? Index range usize. So I should be able to say like self policy min. Oh. Okay, but that will return me the size of values is no. I don't want to do that. I want to just as mutable string from into boxed. If any one of you knows how to actually index strings, I would appreciate some help. You can write in chat because I have absolutely no clue. I've never done it before. Push, pop, try, reserve, split off. Everything except, of course, we can always do chars and collect it into vector, but it sounds slow as hell. Maybe we can look at str thingy. So, here it has get, returns a subslice. Can I like get a char, one char, not a subslice? By char indices get mute lines match parse repeat replace split trim. Okay, but then what if I do this? Oh yeah, that will return me okay, I will just take and create then chars. I will create a vector of this chars because otherwise it will look so ugly. So I'm taking chars and I'm collecting that to a vector. I'm collecting so many things to a vector because often it's the easiest way to proceed. I will call it password chars, and then I should be hopefully able to index it like that. Yes, yes. So it's a vector of chars, and yeah, policy min, and that will be first occurrence. I wonder if it will fail. So We actually can for now just ignore it, because I guess if it will fail, we will get an error and we will fix it, because we can kind of override the string, right? We can also just try to do get. Let's be good Rostasians and do this. We can then say password chars get, password chars get, self policy max, and then I will say let if some first, some second. Oh, if let, of course. And here I also need to put this stuff around so that this is correct tuple. And then finally I can say, so we essentially need XOR, right? We need I wonder, so here is, does it do XOR? It does bit XOR. Okay. So how do you typically write it down? Alternatives. Okay, this is like logical sense exclusive, or okay, logical formulas will not work as easy. We can just use if then thing. Password. Or actually no, it's quite complex, quite simple. We can say if P and not Q, or not P and Q. Okay, that makes sense. So first matches will be first equals to self policy letter. That second matches will be second equals self policy letter. So this is, of course, this is reference to char. Let's dereference it. And then we can just say A XOR B equals A and not B, or not A and B. So human explanation of this magical formula. And then first matches and not second matches, or not first matches and second matches. And this will be our return. Otherwise, if we, for example, ran out of letters, we know that the policy is invalid, so we return false. And then solve2 will be almost exactly the same. We will just take this solve2 and we will say blah 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 into policy, and here we literally replace one number, and then we can quickly do the answer thing. So let's see. Oops. Yeah, we will need to do some macro magic to make this stuff work properly. This without us every time needing to change it. But solve2, yes, splendid. Go here. 252. That's not the right answer. Your answer is too low. If you're stuck, make sure you're using the full input data. There are some general tips on the About page. Please wait 1 minute before trying again. You guessed 252. Okay, we did some mistake. Let's write test and try to check some stuff, right? So I will just copy this. I can. So we know that this is incorrect answer, right? We can then run this test. And it will fail because we are incorrect. What? Ah, yeah, solve 2, of course. Yep, because it says, yeah, we got what we should not have gotten. How do you debug that? We will just use this input. From oh, I'm dumb because of course this scene is 0 indexed and this scene is 1 indexed, of course. So normally I would just return a test for those inputs to guess it, if it's correct or not. But here we can just say policy min -1 then. And this is like -1, 2, right? Think so. Yes. So we can then try to run our magical test. Oh no, it will not report the correct answer. We will need to do this instead. 489, that is bigger. So yeah, we solved it. So here we then can switch it to be equality. Let's run all our tests. Yep. So we solved the day 2 both parts, and now we will commit it and start solving the day 3. So day 3. Toboggan trajectory. I really hope I'm reading this word correctly, otherwise this will be weird, but fine. I don't care that much. With the toboggan login problems resolved, you set off towards the airport. While travel by toboggan might be easy, it is certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map, of course you make a map. Advent of Code always contains those grid-like things, so not surprised here. You make a map of the open squares and trees you can see. For example, these aren't the only trees though, due to something you read about once involving arboreal genetics and biome stability. The same pattern repeats to the right many times. You start on the open square in the top left corner and need to reach the bottom below the bottommost row on your map. So we start here, and we need to get here, or here, or here, or here. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3 down 1. All the trees you would encounter for the slope right 3 down 1. From your starting position at the top left, check the position that is right 3 and down 1, then check the position that is right 3 and down 1 from there, and so on until you get past the bottom of the map. So you need to repeat this stuff, I guess. That is interesting. The locations you check in the above example are marked here with 0 where there was an open square next to where there was a tree. So we start here, and then we need to go right 3, 1, 2, 3, and down 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay, makes sense. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Ooh, that is fancy stuff. Okay, I guess I'm too lazy to work on interpreter. I will just create a short file for now. And here I will take my puzzle input. Yep. Then we will need to model this stuff, right? I guess the most compact representation of this thing will be locations of trees, right? So like we only need to care about things that are not occupied, or things that are only occupied. That will allow us to use very little memory for representing this state. And then for repeating it infinitely to the right, we can just do division. We can just use integer arithmetic, I guess, to check if we get the something present in the location that is the like our position module width of the thing, I guess. Let's try it, I guess. Let's do D3 and D3 Rust, and here we can do solve. Where in essence we, as usual, get our input here, and then we need to parse it. So let's call it tree map and parse our input. For now we return none, and we will just debug the tree map. What will be our tree map? It will be a hash map. Oh, no, it will be actually, let's do a custom type for that. Collections hash map. Yeah, by the way, the stuff is broken because we need to add module here. We just say struct tree map, which will have only one thing. It will be 3 locations, like trees. Or actually, it doesn't even need name, right? We can just do hash map from from a tuple of x and y to actually even hash set. We don't need any map, right? We need to check for being present. And here then we have parse. Let's do it a bit nicer. And this stuff is I derived debug. Oh yeah, input. And then what we do our typical things. So we do trim end, then we do split, we split by line. And then for each of those, we start with fault, we create hash set, we say we have accumulator, so trees, and we will have line. We will probably need also to index it, right? So enumerate. We don't care about our system of coordinates, right? We only have like relative distances here, so it doesn't matter. So then it will be x in line. Y, and here we have character, and then so we do double fold. We go through all lines, and then for each line we go through all characters. We use enumerate to get x and y coordinates. So like for each line, enumerate will return x coordinate from the top to the bottom, starting from 0. Actually, that's like y coordinate, right? Do we care? Right, 3 down 1. Well, okay, let's care. Let's call it correctly, because otherwise we will get confused. Then y coordinate we get for each line, and for x we get, but they go from top to bottom. So goes from top to bottom, and starting from 0. X goes from left to right, starting from 0, right? And then tree will be, yeah, if actually trees I can just do this. Oh my god, it will be easier to just do mutable set, I guess, here, right? Because otherwise we'll need to create a new set. This is functional programmer and me. I always want to just do a number of higher order functions, but in this case, we don't actually need to do that. We can just do a bit simpler stuff. We can do new, and that will be trees, and then so here we will say for, right, instead of folding it, and then we can do this stuff, where we will need to do something like, why don't we like it? Oh, I forgot in here. Then expected found. Yeah, sure. So and then here we can say if char is equal to this thing, then we insert X and Y stuff. Yeah, insert unnecessary parentheses. So that's our thing, I guess. We can then do the typical magic for tests. So model tests, and here we can do test and function tree parser works. We will have a lot of parsers. That's one thing that we can be certain of when we work with awk. Yep. We, by the way, also will need to somehow record the width of the field, actually. But okay, first let's see if that thing works already. So yeah, we need to do the typical incantation. So we take file system, we take everything from the upper thing, and then we just do this. We say input is a fast read to string. Yep, and inputs D3. Yep. By the way, I can remove that stuff. And then we just do solve input. And that, of course, cannot read for day 3. So we for now just do that. The test doesn't do anything yet. It doesn't contain any asserts, but we get some output. So what we get are coordinates, right? For example, 8, 105. So 105, let's go to line 106 then. And then 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that looks correct to me. So that number we can use. And then 9, 105 is definitely empty, and 0, 0 is empty. So we can do, actually, let's do it properly. Let's say parser parsed. Yeah, let's call it trees. Because we also will need to add widths. Yeah. And yeah, I guess we just say tree map parse, get parsed, and then we get trees, and then we see contains, so 8, 105. You can just do assert on that. So, and then we can do that it doesn't contain the next character or the previous character. 9, let's do 7. So 0 should be actually there. So, and the length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 31, really. This is this moment where I always want to just do this. A bit of a cheating. 31, yeah, I counted correctly. Okay. I was for a second thinking that maybe I'm crazy. So, and so 0 should be there and 30 should be there. But 29 should not be there. So then for 0, for the top left thing, we know that it's not there. And for the top right thing, it's also not there. Which will be I guess 323, which will then be 322, right? And but this will be 30, 29, 28, 27, 26. So this should be there. 6. I think I'm correct or not. 30. Yeah. Okay, let's see if that stuff will work. Something failed. 29, 105. Oh no, of course it's not correct. That should be 30. I meant, I know, 29. It actually should be this thing. 106. So this is 30 and this is 29 and it shouldn't be there. Yeah, I forgot this thing, I guess. So something's still off. 26, 322. That actually should be contained there. So, okay. I'm making more mistakes in my test than in my code so far. Okay, it seems to be correct now. Let's move all contained trees here and all non-contained trees here, so they're at least uniform. Okay, parser seems to be working. Next thing, we will also need to add widths. So usize as well. So width will be none, I guess. So it's just the length of line here. So our width here will be 31. Oh yeah, we need to do assert equality, right? Let's do it like that, a bit more logical separation. Okay, parser is working for this stuff. Now the main thing for us is to just being able to move around it and being able to replicate this behavior where we kind of copy it to the right infinite amount of time, depending on how much stuff we want. So we essentially need a custom index trait, right? I think let's quickly check it for indexing an immutable. So here we can implement it, and then we can add logic for actually updating our x and y multiple times until actually we exit, right? Because no, we can just return none. We don't need to care about that, I guess, for now. So let's I'll close this stuff for now. We don't need it. Let's do implementation for a trait index for tree map. What will be our output? It will be just Boolean, right? So do we have a tree or do we not have a tree at that index? Then we can use this. Oh, use size, of course, for tree map dump. And now we can implement missing member. So this is our x and y, right? And then we see if self. So why we say, or x is essentially x module self. I guess it will be something like that. Self width, right? Yeah, I think so. And emulate copying everything to the right infinite amount of times. And then self trees contains x, y. I wonder, is it... Oh, it always needs to return a reference for that. Index self output. How can I actually tie it with lifetime of my self thingy? Self contains returns just pool. Can I just annotate it explicitly? Will it understand what I'm talking about? Let's see. Owned by the current function. True. Oh, let's check then how to implement index. So because oh, so our return value is not a reference, and if somehow so you cannot really... Wow, that's weird. The index trait is meant to return a borrowed pointer to a member of self. The signature from makes it impractical to implement to have the behavior described as it have to store. What index? Yikes. Well, this use case actually matches intuition for index perfectly. Oh, this is so dumb. Okay. We can just move it to be then, I think there is no simple solution, so we will just move it to be a simple function, which sucks because we will need to, yeah, we will need to make sure that it then returns something. But I also wonder, is there like, maybe there is some other trait that can do something what I want? So like slice index 9 doesn't seem so. Maybe index mutable also will probably return a mutable reference, right? Yep, it returns mutable reference. Index into slice index. Okay, there is nothing like we want. Well, fine. Let's just do an old school function then. Let's code is3 then, and it will return bool. And logic will be pretty much index. It will be, or like then we can call it also chords if you don't care. And then we can do this without all the reference craziness. And of course, yes, we also need to accept reference to self here. And that we will call chords. Can I actually match it here? Can I do this? Oh, wow, it's a valid syntax. I didn't know. Okay, cool. And then this stuff I can just drop. So it's is3, and then we also need to implement some kind of movement, right? So I will just say, I will not try to model everything for now. I'll just say move right 3, down 1. This is pretty cool, using pattern matching in this place. So when does it terminate actually? We can yeah, I guess we will also need to put height here after all. Line. Oh no, we can just do it like that. So we always update it. Height equals some line length. No, some y. Some y plus 1. Do you want? Here, let's do it. So y plus 1. And in center say height. And I think it was like 3 to 3, so that's our height. For now, I will comment this out to check if we parse it correctly, and I will run the tests. And yep, it passed. So then we can go here. So let's implement it inside then. Because then we want to terminate the moment we get. Let's do option. So what will be our x? All the trees. For when we go, so this was 0 and this is 1, 2, 3, right? So x will be x plus 3 and y will be y plus 1. And if y is less than yeah, we take reference to self. We return some xy. Alternatively, we return none. So, and then let's do our solution. So we finally can solve the puzzle itself, which will be then tree map. What is our position here? We start by 0, 0, right? And then we need to just repeat it and count the number of trees. How many trees would you encounter? Top left corner. Okay, so position is then sum 0, 0. And while and it's mutable, of course. Position is sum. Oh, actually, I think we can do, right? That should be a bit nicer. So while that is the thing, we can, while we get a new position, we can say trees count starts with 0. Is 3 position. Right? And then we just need to move. So we say tree map, move right 3 down 1. We take position. We say position is equal current position. Let's rename it. And then we just return some trees count. So that should be the solution to the puzzle, hopefully. Let's just add it here then to a magical fake REPL interface. 189. So, yep, we solved day 3 part 1, and now we can move to day 3 part 2. But first, let's quickly add a test. How did I call it in D2? Oops, not the input thing. Part 1 solved, yeah. Part 1 solved. Trees count. So, and this is of course a test. So let's test everything. Yep. Okay. So, time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Determine the number of trees you would encounter if for some for each of the following slopes you start at the top left corner and traverse them up all the way to the bottom. You already checked. In the above example, the slopes would find 2, 7, 3, 4, and 2 trees, respectively. Multiply together, these produce an answer 3, 3, 6. What do you get if you multiply together the number of trees encountered on each of the listed slopes? So, I guess we just need to provide a logic for checking this now for multiple things. So we have hard-coded the logic for like move right 3 and down 1. Instead, we will need to accept a parameter. We can just say right, which will be down, which will be this. And then we can rename it to move. Oh yeah, move is a keyword in Rust. Move with slope then. And then we just do this, right and down. That of course doesn't work anymore. So right 3 down 1. And now we can run our tests again. Yeah, so it still works. And we just need to extract the functions that we use for checking stuff. So tree count. let's go call it tree count on slope. I really like this kind of stuff because it's very real world. You know, you need to refactor things that you just wrote to make it when new requirements come in. I think it's one of the cooler things about Advent of Code. And this will be yeah, this will be just usize, right? And of course, gmap will be a reference to self. And this then will be on slope. One thing that I don't like about Rust, I think it's one of the main words for me, is that it doesn't have keyword arguments. Keyword arguments are amazing. The best way would have been if it took features from OCaml, where you have those labels, and labels are also tracked in type system. I think it's really cool stuff. But sadly, that didn't happen. Yeah, of course, we need to convert it. So our tests should still pass with those changes. Yes, they do. And now we can just solve part 2 directly. So write 1, down 1. Write 3, down 1. Oh, it's not the most beautiful solution. We could have put it in a vector and then... Actually, let's put it in a vector. I will just do slopes, and here we will have write 1 down 1, write 3 down 1, 5 down 1, write 7 down 1, write 1 down 2, right? And then we have answer, which starts with 1, of course, because we are doing multiplication, right? We just go slopes, iter, fold. Actually, I can do into iter here for simplicity, do not care about all the dereferencing stuff. And we start with 1, and then for each slope, we get first accumulator, yes. So we get write down, we get then answer, and we multiply answer by the tree map, tree count on slope, write down. You see, it's even like half of the solution is just autocomplete now because we named everything consistently. And that we return, and in the end, that will be our answer. Okay, it doesn't like something. Let's see what it doesn't like. Found tuple. Oh yeah, I mixed it up, of course. Answer should be first because it's accumulator. That thing should be second. And that kinda is that. So let's make it executable too. Oops, not part 3. And yeah, we probably will need to do macro magic eventually to make it a bit nicer. Let's do cargo run and see where we at. So D3. Ooh, wow, that's a big number. Let's see if it is correct. Yep, that's the right answer. Okay, that was statically typed language paying out big because the part 2 was so trivial to implement. It was so easy. That's nice. Let's quickly write a test for that as well. And then I think I will be done for today. I guess, yeah, I will tell you a bit more about plans for the next days later on. So let's just copy that. Solve to answer. Oops. Yep. So, and now we should see that all 3 tests pass. Yep. So, thank you for watching. Those were days 2 and 3 of Advent of Code with Rust. I completely forgot regex. So I think I very rarely use them in Rust. I mostly do this stuff with Python or Elixir. So that was, I think, second or third time when I use them. Then another thing that was interesting, of course, is that the day 3 was way simpler for me to solve than day 2, funny enough. I guess, and in this case, all the data modeling really paid off because we had a nice domain model, we implemented parser, we then were easily able to abstract the whole tree counting logic, the slope thing, and just write a couple of lines of code essentially to solve the last part. I find this is kind of the power of the statically typed languages, right? It's something that is often advertised that it's easy to refactor, and here it paid off. Real world, it's not always so clean, sadly, but it was really cool. Another surprising thing today was that Rust, apparently, this indexing is not really useful if you're not returning reference inside some struct. So didn't work. We needed to invent our own method. That's a bit of a shame. And that's it, I guess. I will be back with another stream on Sunday. We will be doing days 5 and 6. Day 4 I will probably do on my own on Saturday to also enjoy it a bit, but I will show you the solution and also will discuss it in the beginning of the stream. Thank you for watching. See you on Sunday.